All right, folks, it's Bass Action, back in action here. In this video, we are going to learn about 30, 60, 90 triangles. We're going to learn where the extended ratio comes from, how to use that extended ratio, and a couple examples. Now, we're not going to do all the examples here, but we are going to go through where the extended ratio comes from in these first two. So let's just jump into the extended ratio. So the extended ratio for every 30, 60, 90 triangle is 1 square root of 3 and a 2. Now, right now that seems really abstract and you don't know where that's coming from or what that means or how to use it, but don't worry. This is the key of what we want to understand for a 30, 60, 90 triangle. Now, what is a 30, 60, 90 triangle? Let's come over here and look at this equilateral triangle here. I know it's an equilateral triangle because this is 60 degrees. This has been bisected from this nice altitude that's coming in here, which means this triangle had to be isosceles, which is going to make this angle down here 60 degrees. Well, if it's these two are 60 degrees, the remaining angle also has to be 60 degrees, but this altitude will bisect this angle up here up top. Now, if that's the case, then what we're going to do is we can fill in this little 30 degrees right here. So a 30, 60, 90 triangle is simply a triangle that has a 30-degree angle, a 60-degree angle, and a 90-degree angle. And we can create this nice 30, 60, 90 triangle every time from this nice equilateral triangle that we have going on here. So let's go ahead and highlight this 30, 60, 90 triangle because that's where we're going to do our analysis. And I mentioned that this triangle is equilateral, which means if this side here, I should say, if each of these pieces are x, then this whole side of this equilateral triangle is 2x. So I can actually put that again over here. Now, let's look at this highlighted triangle. I have one side in the triangle that's an x. I have another side in this 30, 60, 90 triangle that's a 2x. This 2 on that hypotenuse there, or the side of the equilateral triangle, is in fact this 2 over here. Okay, so if we're looking at the little 30, 60, 90 triangle, the 2x is on the hypotenuse. So what we want to remember is that 2 is associated with the hypotenuse. Okay, now this x right here has an implied coefficient of it on it of a 1. Now we don't usually write that, but that 1 right there is this one right here. Now this little side, this x, is a leg in the triangle, and this leg is across from the 30 degrees. Now I've got two legs here. One leg is across from 30, the other leg is across from 60. The leg across from the 30 degrees is called the short leg, or just short. Okay? So our last thing that we're going to look at is this radical 3. Where is this radical 3 coming from? So we're going to look again at this little triangle and we're going to do a quick Pythagorean theorem. So we're going to take our hypotenuse and we're going to square it. We're going to square each of our legs and we're going to solve for this a. So if I square that side, I'm going to get that hypotenuse, I'm going to get 4x squared and x squared plus a squared. Let's subtract. That's going to give me a 3x squared and an a squared. And now I'm going to go ahead and take the square root of each side, which means I can take the square root of 3 and the square root of x squared. So this a right here is a square root of 3 times x. And sure enough, there is the square root of 3 that we were looking for. That square root of 3 is now going to be associated with the long leg. Square root of 3, x, is across from the 60 degrees, or the long leg. Now, what we want to do is we want to apply this. How do we use this little extended ratio to find values in our triangles? So what we're going to do is we're going to start off with this one right here. We know this triangle is a 30, 60, 90 because there's a 30, there's a 90, so the last angle here has to be a 60. Then if we look at the one measure that was given to us, this 4 radical 3, it's across from the 30 degrees, which means the portion of this triangle that we've been given is the short. So we've been given this short. Now the short is the most important part of the entire extended ratio. Anytime you want to find something, you always need the short. So we have the short. So if I want to find, if I have the short, but I want to find, let's say, the hypotenuse, then I can look at my extended ratio and say I'm right here and I want to come over to the hypotenuse. Well, the short is certainly going to be smaller than the hypotenuse, so if I want to get bigger, I would multiply, and I'm going to multiply by this factor of 2. So I'm going to take my 4 radical 3, I'm going to multiply it by 2, and that's going to give me 8 radical 3 for that hypotenuse. Now, I also have the short, and I can use that short to find the long. Now, normally we won't write all this out, but it's good for the learning part right now. So again, I have the short, I want the long. So I'm going to go from here to here. The long should be bigger, so I'm going to multiply by this factor of 3 because I'm trying to get bigger. So I'm going to take my 4 radical 3, I'm going to multiply it by a radical 3. Of course, radical 3 times radical 3 is just 3, so my long leg is 12. And I could even put that up here on the triangle. Now, the last one we're going to look at is a little bit more complicated, and we're going to find the area of this equilateral triangle. Now, what we want to understand is that to find the area of an equilateral or any triangle, we want to do 1/2 base times height. Now, to do our 1/2 base times height, we can of course say, all right, I'm going to do a 1/2, and I could recognize that I'm going to do my base, and I want to do my height. Now, the height has to be this whole thing right here. So we're going to have to come back to that because we don't know what that is quite yet. But we do know that the base of our triangle is clearly going to be 42. It's got to be this whole side together. Now, what we want to do is we want to look at this tiny little triangle that I've drawn in here for you, because this is going to help us find what we need. Now, if the triangle was in fact equilateral, as I told you, then what we're going to do is we're going to recognize this angle here would have been 60 degrees. And since I've already marked that this was bisected, we know then this tiny little angle right here is going to be 30 degrees. So when I look at this little triangle I gave you, there's a 90, there's a 30, so this angle up here is going to be 60. So we have, in fact, a 30, 60, 90 triangle again. Now this time, I didn't start you off with the short. I didn't give you the piece that was across from the 30. I gave you the piece that was across from the 60. So the little piece that I gave you is actually the long. Now, to get the height of the triangle, there's a couple ways to get there, but right now we're going to do it the long way with all of our pieces. We're going to go from our long to our short, because remember, the short's the most important. So I'm going to go from the long, now I'm going to go backwards to the short. I'm going to go from big to small, so I'm going to divide. So I'm going to go from my long to my short, and that's going to give me a 21 divided by, this time, my square root of 3. Well, I'm going to write this over here a little bit better. 21 over radical 3, we would want to rationalize that. And of course, radical 3 times radical 3 is 3, would reduce with the 21, will give me a 7 radical 3 for the short. So this piece right here is 7 radical 3. Now, what I want you to notice is that the hypotenuse in this little tiny triangle here is the same as this remaining portion of the height of my triangle. And now that I have my short, I can go back to the idea that we did on example 1, short to the hypotenuse, I can multiply by 2. So if I take this 7 radical 3 and I multiply by 2, then this piece right here will become 14 radical 3, or I'm even going to write it right here as 14 radical 3. So I'm going to take this piece and this piece and add them together for the height of my triangle of 21 radical 3. Now, little side note, if in case you remember this from your chapter 5, in an equilateral triangle, this point is the median. The median is going to divide this segment in a ratio of 1 to 2. So sure enough, we have our 7 radical 3 and our 14 radical 3. Now, if we want to finish off our area computation, our 1/2 times our 42 times our 21 radical 3 is going to give us 441 radical 3, and I'm going to say units squared. The ability to find the area of an equilateral triangle is a crucial skill in this semester and in this chapter, so make sure that you do feel comfortable with this example or you jot down any questions that you have.